In this video for section 5.2, we're going to solve linear systems with 3 variables and 3 equations. Basically, the process for this is just applying the addition method 3 times. So what we're going to do first is take 2 different pairs of equations and use the addition method to eliminate the same variable from both pairs. That's important. Then we set our 2 resulting equations together into their own system, use addition on that. That gives me 1 variable and substitute to find the other 2 variables. So there's a lot of steps to this problem, but it's a little bit repetitive, so it shouldn't be too bad, hopefully. So we're going to look at example 2 from the textbook. So here's the system that I want to solve. I have 3 variables, x, y, and z, and I have 3 equations. Now, there's a little bit of strategy to this in that you want to look for something where you have either an x, a y, or a z that is by itself, or if you have something where the other coefficients are factors of one of the coefficients. That makes your problem a little bit easier because you can only multiply one equation instead of having to multiply both. And the more steps that you can take out, the less likely it is that you're going to make a mistake. Now, for this one, I do see here that I have this 2z and 4z, and so those are going to be a little bit easier to work with. I'm actually going to do the x's because that's what I did in the solutions in the notes, and I want to follow that. So the textbook will eliminate the z's, and they're going to take advantage of that. It doesn't really matter too much. You can kind of just pick something, but if you want to be strategic about it, looking for things, or again, you have a variable by itself or a factor of another coefficient, that will make it a little bit easier. So I'm going to start with equations 1 and 2, and I'm going to eliminate x. Now this is important because once I choose which variable to eliminate, I have to eliminate that same variable in my next pair as well. So we're eliminating x from 1 and 2. So equation 1, I'm going to copy that down here. 5x minus 2y minus 4z equals 3. And 3x plus 3y plus 2z equals negative 3. So if I'm eliminating x, I need to multiply the top equation by 3 and the bottom equation by 5. Since they have no factors in common, I just need to get them both to be 15. And I need to pick one of them to be negative. I'm going to go with the bottom one here. There's lots of different ways that you can do this, just different choices that you can make. So part of your answer is not necessarily going to look the same as mine if you make a different choice. And that's totally fine. You should end up with the correct answer in the end. So we're multiplying by 3 here. Everything is multiplied by 3. And multiplying by negative 5 down here. So negative 5x minus 15y minus 10z equals 15. And then I'm going to add those together. Now the x is canceled out, which is what I wanted. And then I can add here, it's negative 21y minus 22z. This is going to add to positive 24. And then once I get there, then I forget about what I just did and I pick another pair. So I'm going to pick equations 2 and 3. And again, I need to eliminate x. So I'm going to copy these down here. I could have picked 1 and 3. That would be my other option. I just need to pick a different pair than I used the first time, because otherwise I'll end up with the same equation and that won't really help me very much. So picking 2 and 3 here. And now I'm going to again eliminate x. So I'm going to multiply top equation by 2 and bottom equation by positive 3 because I already have one positive and one negative. So that's 6x plus 6y plus 4z equals negative 6, and negative 6x plus 15y plus 9z equals 9. So my x's cancel again. 6 plus 15 is 21. Y plus 13z equals 3. So now I'm going to put these two equations together into a system. Now this worked out really nicely for me because I actually don't even need to multiply by anything here. So once I get this copied down, what's going to cancel out? Well, the y is going to cancel out automatically because I have negative 21 and positive 21. There was no way that I could have predicted that that would happen. It just kind of happened by luck. So you might need to multiply either one equation or both equations at this step. Like I said, I just got lucky and I didn't have to. So negative 22 plus 13 is negative 9z, and 24 plus 3 is 27, and then I'm going to divide. Now, the way that the book problems are for this section, you should always end up with whole number answers. And in the previous section as well, when you're doing the systems with two equations, if you didn't notice, the problems will always end up with whole numbers. If you get a fraction or something here at this point, you might want to go back and check your work because that probably means that there's a mistake somewhere. So once I get my value for z, I'm going to put a box around it here, I'm going to plug in to find my values for y and x. So to find y, I can plug into either of these two equations right here that have just the y and z in them. I can plug in for z and then solve for y. So I'm going to pick the one that's right above here, 21y plus 13 times negative 3 equals 3. So plug in negative 3 for z and then solve. Sometimes the numbers on these can get a little bit ugly. This one wasn't too bad, but I've seen it get a little weird. But even if they're weird numbers, in the end, you should end up with things that divide nicely and give you nice whole numbers. So this one is going to be 42 divided by 21 is 2. So y equals 2. Now I have to go back to one of my original three equations and plug in the y and z that I just found and then solve for x. I'm going to use equation 2 because I can see it right here on my screen. So we have 3x plus 3, plug in 2 for y, plug in plus 2z, oops, I should have spaced that out a little better, plug in negative 3 for z, and that equals negative 3. So I'm using this equation right here, right now, 3x plus 3y plus 2z equals negative 3. Plugged in 2 for y, negative 3 for z, and now I need to solve. So 3 times 2 is 6. 2 times negative 3 is negative 6 equals negative 3. That worked out kind of nicely. I'm running out of space on this page. So we have 3x plus 6 minus 6 goes away. This is just regular solving equation stuff, and then divide, and I get x equals negative 1. Whoops, negative 1. So the way that this is going to look in the homework is, again, they're going to have the squiggly bracket for you. And these problems are actually nice in the homework because instead of making one box in here, it's actually going to be 3 separate boxes. So what that means is that you'll get partial credit if you have one answer right. And it actually has the parentheses in here for you already, which is nice. So this is what you're going to see in the homework. You're just going to type in negative 1 for x, you're going to type in 2 for y, and you're going to type in negative 3 for z. So x, y, z, z always comes after y in the coordinate pairs. So what you should do next is look at checkpoint problem number 2. Do this in your notes, check your answer, and then move on to the homework.